I am Scott Ward, Principal Solutions Architect with Amazon Web Services. I'm based out of Seattle, Washington, and I work on our partner team, and more specifically, I work with our security technology partners. So my focus is working with these partners, primarily with their product and their engineering teams on the things that they're building for customers to use on AWS to help them with their security goals. We do a big focus on kind of just general AWS best practices and then put a big lens on that as it relates to security and make sure that what they're delivering is really lining up for what customers want and need when it comes to being able to have security that they're confident in when running on top of AWS. Tenure-wise, I've been with Amazon or AWS for just a little over 18 years now. I worked in our internal financial systems team for 13 years on the engineering side in various developer roles and management roles, and I've been in this role at AWS for just a little over 5 years now. So today we're going to talk about AWS and Okta. We're going to focus on kind of some general best practices. I'm going to highlight a few level setting items as it relates to AWS, talk about why Okta is such a good fit and where that adds a lot of value, and then go a little bit deeper about some other ways that I'd really like to advocate that people start exploring when they're talking about using Okta with their AWS accounts when it comes to kind of moving away from the browser-based management console and supporting some of the new architecture approaches that our customers are taking when it comes to actually just having and managing an AWS account. I'm curious, people in the room today, who here is responsible for administering an AWS account today? Okay, and using Okta in some form or other with your AWS account as well? Okay, cool. So hopefully I have something for you existing AWS Okta users and anybody who isn't doing it today or considering it. I should be able to give you something to walk away with as well. I'm happy to stay and answer questions at the end. I believe we're the last session of the day, so you've got me for a couple hours if you want for questions. And anything I can't answer, I've got a big stack of business cards. I'm happy to trade with you and follow up with you at a later time. So to start off with, why is identity for AWS so important? So having an identity strategy for an AWS account or for your AWS accounts is really a key thing to have as part of your overall AWS strategy. And I encourage this for any customer, any customer of any shape and size who's using AWS. It's important for you to understand, what am I going to do when it comes to identity? How am I going to let people and things actually be able to interact with my AWS account? There are over 130 different services that you can run and use on AWS. These are ultimately tied to an AWS account. You go into an AWS account and you configure, you turn on, and you start using these services. And you can use these services to store data, to power your workloads, to power your applications. And so there's a lot of important things going on with those services and those resources inside your AWS account. So it's natural that those types of things would be very attractive to a malicious user who may want to get at your data. They may want to manipulate your workloads or even just utilize your resources for their own gains. But there's also just a need to make sure that your trusted employees are operating within the right bounds, that they're doing just the things that they need to be able to do and that they're doing them when you want them to do them, and that they actually are who they say they are. So having that identity strategy for AWS is super important, and it covers a lot of different areas. When it comes to identity for AWS itself, identity is mainly controlled through the AWS Identity and Access Management Service, or IAM. So IAM is a service that you use to control access to the resources that are running in your AWS account. And there's a few different key components of IAM that I want to highlight that you should be aware of. So there's the ability to issue long-term security credentials. And so those are issued in two different ways. One, you can just set up a user and give them a username and a password, and they need to present that username and password in order to be able to log in to the AWS account and interact with those services. And you have the ability for that password to be able to set the password complexity and how long until they have to rotate it and how many times until they can reuse the same password. But there's also a need for people to actually be able to programmatically interact with your AWS account. They're like, look, I just want to, I'm happy at the command line. I don't want to see the browser. They want to be able to access and interact with your AWS account as well. And so you can also vend out long-term credentials for that. And we call those access keys. And an access key has two parts. There's the access key ID, and then there's a secret access key. And just like a username and password, you have to present both of those in order to be able to actually make a successful API call against AWS. And then there's temporary security credentials, and these are really cool. They're very similar to the access key that I just talked about, but they're time-bound. When you have temporary security credentials issued to you, you have the ability to get them for as short as 15 minutes or as long as 720 minutes. And they're very similar to the access keys in the sense that you get an access key ID, a secret key ID, but you also get a session ID. And you use these the same way that you would if you were using a long-term credentials as far as calling AWS APIs, but as I mentioned, they're time-bound, and so at some point in time, you'll have to re-authenticate to be able to get new credentials. And so that's cool because you don't have long-lived credentials kind of floating around in your corporate environment or potentially on somebody's laptop who's going to work from the coffee shop for the day. The risk is significantly lowered because you are using these short-term credentials for interacting with your account. IAM also gives you the ability to control permissions. You use IAM to define the permissions as far as what people or things can do in and against your AWS account. You define named users. So if you want to be able to just set up username and password or long-lived security credentials for somebody to get into your AWS account, you can set them up just as a user as you would in many other applications. And then you can also define roles. Roles are really neat because they're there to allow somebody or something who is not a named IAM user to be able to actually assume and get permissions to interact with your AWS account. And roles don't support long-term credentials. The only way you can use a role is through short-term credentials. So you go in and what we call assume a role, and if you have permissions to use that role, you would be vended back short-term credentials, which you can then use for the life of those credentials, and you will be able to interact with the account based on the permissions given to that role. So a little bit deeper on the permissions part. So permissions in AWS are controlled through what we call policies, and policies are nothing more than a JSON formatted document that you author that outlines for that particular policy what actions are allowed, what actions are denied, and what conditions must be present in order to either allow or deny that particular action. So you define these permissions for a principal, which would be a user or a role inside your account. And these permissions are really cool because they control access in a lot of different ways. You can define a policy and apply it to a principal, and it will be effective for how they interact with the management console in the browser, if you're using the command line interface, or if you're using the SDKs. One policy will work for all three interactions because at the end of the day, it's controlling access to the actual APIs. And so policies are authored to allow or deny actions. You can go super high level and allow all actions. You can allow permit all actions for a particular service. For example, EC2, you could say you have access to all of the actions that go with EC2. You could allow the ability for somebody to just launch an EC2 instance, but maybe deny them the ability to actually stop or terminate an instance. Or you could apply conditions that say, you can launch an EC2 instance and I'll let you stop an instance, but only if it has a tag that has the environment of test on it. So you can go very high or very deep as far as how you define these policies. And a best practice with these policies is to use a least privilege model. So focusing on understanding why am I authoring this policy, who's going to use it, and matching that policy up and the actions in that policy with what that person is actually going to be doing in your AWS account so that you are limiting the things that they can do outside of the scope of their normal role and ensuring that they are doing just what they're supposed to be doing as part of their job role. So building on that, now that you've actually gone out and defined policies in AWS, one thing that I encourage my partners and customers to do is that actually give an audit to those policies every once in a while. You know, somebody said, I need this policy authored and it's going to be used for this purpose and by this person. But it makes sense to go back and actually check that every once in a while and say, is it being used in the way that it was intended? With AWS, we actually have a feature now called the Access Advisor, which is just nothing more than a tab when you go and look at a role or a user, and you can actually drill in and see how is this policy that's tied to this principal actually being used. And it will tell you the last time it was accessed over a 365-day time period. So you can get a sense of, look, we gave this policy access to EC2, but it hasn't been used in 165 days. So do you actually need these permissions, or is this role maybe like not even valid anymore? Maybe we can just retire this and strengthen our security profile as far as what policies are out there or what access people or things might have. So I encourage you, at some regular interval to actually audit your policies and verify, are they configured the way they need to be, and are they being used in the way that you expected them to? Now at scale, going into a browser-based console and going into a tab for every user and every role, and potentially in every account really doesn't make sense. So we recently announced the ability to actually do this through APIs. So you can actually now make an API call to get the details about every role and policy that you have and understand the last time it was actually used and accessed. And you can, in a more programmatic way, actually formulate, these are the roles and these are the parts within the policies that I may want to further audit and take a look at to determine, am I actually set up right and are they using it appropriately? So administering identity and access management has always been kind of an interesting challenge because you're giving somebody the ability to set up and define principals and the permissions that these principals can have in your AWS account. But you are also kind of putting a level of trust into that person that says, look, I'm expecting that you're not going to also give yourself escalated permissions or more permissions than you're supposed to have, or I'm going to have to build in extra monitoring to actually make sure you're doing what I expect that you're doing. So it's always been a challenge to make sure that you give somebody these access, but that they're doing the right thing. So permission boundaries are a way for you to define kind of an authoritative, this is the boundary that I'm going to allow people to operate in. And regardless of what permissions you give somebody, they will not be able to operate outside of those boundaries. So look at it as like giving your teenager the keys to the car. I've got a 14-year-old, that's going to be happening in a couple years. You want them to have that experience, but you also are expecting that they're going to follow some rules and some conditions. But you're not in the car with them all the time. So sometimes it's an audit after the fact. You might be checking the odometer, see how far did they actually drive, or you might get a speeding ticket in the mail a few weeks later that might show that, yep, you didn't do what we expected. Some car manufacturers are actually making keys now where you can actually program those keys, and they will actually enforce some conditions on how the car should be operated even though you're not there. So that's starting to allow you to kind of do more of a real-time enforcement. And so permission boundaries exist in that way because, handing an operational or a development person the AWS account, you're basically giving them the keys to the account if they have the ability to interact with identity and access management. So permission boundaries are a way to establish controls so that regardless of what the developer or the operations person wants to do, you can ensure that they are operating within the boundaries that you have defined. So a good way to look at this is through a Venn diagram. So if we look at the permissions boundary on the left here, that's defined by the overall administrator or the person responsible for the AWS account. And this is the scope of what I'm willing to allow this particular permission structure to actually be able to operate in my AWS account. But you might have your a developer or your operations person actually define a different policy that gives a different amount of access and control in the account. The principle that identity-based policy is assigned to ultimately will be able to have the permissions for the intersects here. Whatever kind of matches between the identity-based policy and the permissions policy boundary is ultimately what the person will be able to do. So you're able to enforce and make sure that people are operating within the bounds that you're okay with through the use of permission boundaries and still allow people the flexibility to be able to administer and give people permissions within your AWS account. So when it comes to identity in AWS, we consider federation to be a best practice for using your AWS account. And that's why Okta is so important, because it makes it easy for people to be able to have an identity strategy that includes federation into the AWS account. And why is federation so important on AWS? Well, one, it helps to remove the need for many of those named identity and access management users that I talked about earlier. It gets you to a point where you have the ability to have all your users defined in one spot, which is generally some sort of a corporate directory that you may have. It helps to ensure that you have consistent password policies. You know, if you're setting up these named IAM users in AWS and you've also got this corporate directory over here, you have two sets of username and password combinations that you're having to manage now. They might have different rotation policies. They may have different strength policies. And if somebody is removed from your corporate directory, they still exist over here in your AWS account, and you've got to have another workflow to actually go to remove them, or somebody has to remember that I've got this user set up over here. So it helps you to centralize and make sure that you're kind of controlling your identity in one spot. And then a cool thing here is also it extends the MFA options. So AWS has a few MFA options around Gemalto tokens and YubiKeys, but they're bound to named IAM users. And we have customers who want a lot more when it comes to MFA, whether it be Duo, whether it be SMS, email, biometrics. And companies like Okta allow our customers to extend it and enforce that MFA before people come into the AWS account so that they can make sure that the right challenges and the right security is being placed to the people that are ultimately accessing their AWS resources. So when I talk with customers and partners a lot, we do a lot of architecture deep dives, and one of the things we talk about is, what are you doing to actually control access to your AWS account? And I regularly hear, look, I'm using Okta to control federation, to allow people to actually get into my AWS account, to that management console, the browser-based way that you interact with AWS. I hear that very regularly, and I think it's awesome that people are taking that approach. But a few minutes later in those same architecture reviews, I bring up the question of how are you controlling programmatic access to your AWS account? What about the people who want to be able to run scripts, or they just want to call the command line interface against your AWS account? And I hear a different story. They're often like, look, we actually do set up named IAM users for those people. We generate them long-lived access keys, and they have those access keys sitting on their laptops. They're writing scripts, they're writing code that are going to interact with the AWS APIs, and they need these keys to be able to verify that all of that works. Or they're an operational person, and then they have scripts that they're going to call from their local laptop, and they need to make sure they have these long-lived credentials to interact with the APIs. There's this disconnect that says, I've got this really clean solution for my management console, but I need to kind of step backwards in time to actually be able to support my command line interface. And so what I'd like to talk about is that there's actually quite a clean way to actually be able to execute on that strategy and make sure that you can actually have AWS and Okta for the command line interface as well. And that's supported by this CLI tool that is available on GitHub. It is not an official Okta product, but it is supported by Okta development. And I think it's a really, really great way, if you've got Okta as your identity strategy for AWS already, to be able to extend that, to be able to cover all the different ways that people would interact with your AWS account. And we'll highlight a few of the key benefits here as we talk about this. But if anybody out here has any sort of a strategy that involves, we don't need to go into the management console all the time, we just want to be able to call the APIs, we have a few scripts that allow us to deploy or to make changes to the account, take a look at this tool to help you be able to be consistent and apply your federation strategy at all levels of how you interact with AWS. So the way this works is pretty straightforward. You're going to download the actual executable. You're going to install that. You're going to install the Oracle or the Java JRE if you don't have that installed already. And then I needed to make a few profile settings in my operating system to set the Java path and to set the path for the actual Okta tool itself. Under 30 minutes, I had this up and running and was able to interact with it. So the way that this works is it's pretty straightforward. If anybody's used the AWS CLI, this is almost an exact replica of that. The command is Okta-AWS. I'm providing, is a profile name, which I'll talk about in a minute. And then the rest of that command is just the normal AWS command. I'm calling the EC2 API, and I'm calling the describe instances action. Now this profile name is important because that's the profile that my temporary credentials are going to be tied to for the amount of time that I'm actually interacting with the AWS account. So we talked about the temporary credentials earlier, and so the Okta tool is actually going to grab these temporary credentials from AWS and store them, and they're going to be associated with whatever profile name I provided as part of my command, my Okta AWS command, and it will look up those credentials every time I use that profile name in the future. Since this is the first time I've made this call, the first thing that's going to happen, I'm going to have to authenticate with Okta. So this is the normal username and password that I have for my Okta account. It's the same one I'm using if I was going to go into the AWS account at the browser level to interact with the management console there. So once I've actually authenticated with Okta, the next step that's going to happen back on the command line, if I have multiple roles that are mapped to me in the AWS account that I'm going into, the next thing that's going to be asked of me is which role do I actually want to use? Pick which one you want for the work you're going to do. Choose that one, and then what's going to happen is behind the scenes, the Okta tool is going to call the assume role with SAML API on the AWS side and pass the SAML assertion across. AWS, the security token service, is going to vend back temporary credentials. Those are going to be stored either in the credentials file, the .aws credentials file, or if you've chosen to store those in memory through the configurations in the Okta tool, it'll be stored in memory. And then at that point, you just continue to run additional commands. Your profile, those temporary credentials are stored against the profile. You can just start running commands until those credentials expire. The Okta tool will detect when your temporary credentials have expired for the AWS side and will automatically refresh those credentials behind the scenes. So you can just continue to use the tool against that profile for the amount of time that you actually need to be running it. At some point in time, you'll have to re-authenticate into Okta itself based on the timeout that's set in that cookie, but it's less frequent than you might have to rotate the AWS credentials behind the scene. There's other ways that you can use this as well. Once you've used that Okta tool to actually authenticate with Okta and receive your temporary credentials and get those set for the profile, if you're more comfortable using the standard AWS command line interface, you can do that and still reference the profile name that you defined for Okta. This works if you're storing the credentials in the .aws credentials file. So in this case, I'm just calling the normal AWS EC2 describe instances and referencing the profile that I defined earlier. Or if you've got some scripts that you've written that are using the AWS SDKs, you can actually reference the profile name directly in your script. This is an example of a few lines of Python where I'm actually referencing the profile name that I want to be used for that particular session of what's going to be running for this particular script. You certainly could make that a parameter that gets passed into your scripts to say which profiler are you going to be running this against, or you could go in and actually edit the script. But the point being is that once you've used that tool to set get those credentials and set it, there's lots of different ways you can actually use that to assist you when it comes to operating at the command line or directly against the APIs. So why is this good for you? Why would you want to be looking at this, or why is this something that you should be thinking about? Well, one, I think it really goes a long way to help enabling automation. So at scale, doing all of this stuff one by one in the management console within one account or across many accounts can be challenging, and it can be time consuming, and it's error prone. So the ability to actually be able to automate what you want to do against your AWS account, whether it be deployments, whether it be configuration changes, or whether it just be retrieving information from that account, you have that ability to automate that and ensure that you can consistently do that action again and again and again. If you're just having running scripts that are, need some consistent commands to be run, once again, an operations person gets a ticket. They need to gather enough information from the environment. If they've got scripts to collect that data, or if they've got scripts that actually would manipulate and change the AWS environment to react to a particular issue that's come up, they can utilize those scripts, and you can ensure consistency that people aren't fat-fingering or typing the wrong commands, because they've been able to use those scripts and authenticate at the command line using Okta as the identity provider. And it helps to remove that need for long-lived credentials. We talked earlier about where we have customers and partners who are creating these named IAM users with these long-lived credentials that have to be protected, rotated, monitored, and by moving to this approach, you eliminate or you significantly reduce the need to have named IAM users in your account and follow what we really consider to be a best practice of these short-term credentials. So in AWS, there's lots of different models that we're seeing as far as how customers use an AWS account. Basically, every customer starts off with one AWS account. They get that account, they start playing around with it, they understand what's possible, they start exploring the services that are there, set some things up and configure it. And over time, those customers use more and more accounts, and we're seeing customers now that have thousands of AWS accounts to support their needs. And we'll talk through some of those use cases here in just a minute. Most customers fall somewhere in the middle here. Probably have more than one account, but probably not thousands of accounts. But the trend we're seeing is that customers are growing the number of accounts they're using to power their workloads and to support their business when running on AWS. So why is one account not enough anymore for these customers? People have done it for years. They've crammed everything into one account and they've made it work. Why is this not a good fit for people? One, some customers have many different teams and they're autonomous. They have their own roadmaps. They do their own thing. Having all of these teams trying to build their workloads, deploy their code, and run their solutions in one account may not be the right thing. They may be contending with each other for resources. One team may have a scaling event that exhausts the number of currently available EC2 instances, for example, and now another team, their service is compromised or is not running optimally because they can't get access to more resources without cutting a ticket and getting the limits increased. Or somebody may be configuring a resource that they think is theirs, but it actually belongs to another team. Putting these teams into their own AWS account allows them to control their destiny a little bit more and allows them to make sure that account is configured and set the way that they need it to support their team. There just may need to be a case where some of these workloads or applications need to be isolated. You may have some very sensitive applications and pieces of data that you want to make sure that you are limiting who can access and interact with it. And since you ultimately grant permissions to access your resources at the AWS account level. But by isolating certain workloads or pieces of data in their own AWS accounts, you have the ability to with confidence and more strongly govern the access to that particular workload or data. There might just be some security and compliance controls that need to be met. If you're running maybe a PCI environment, you need to ensure that people are only using the services that are approved when it comes to PCI. You need to have the right level of controls to the data that exist in that PCI environment, and you want to make sure that you can monitor and allow people to use it with confidence that only the right people are using it and only the right things are happening in that environment. So it may make sense to have certain accounts that are configured specifically for your compliance needs and have the appropriate permissions that only allow the relevant parties into that account. There may just be some business process differences. You may have different teams that have different business processes, and it makes sense for them to be able to have their own AWS account so that they can execute on their business processes appropriately. And finally, a really big one is just billing. AWS bills you every month, ultimately at the account level. So when you get a bill, the account number is always present. So if you are trying to manage and control costs for different teams or for different applications, having them each run in their own account is a great way for you to actually be able to monitor and see what is the usage and what is the cost and who do I need to allocate these funds to, because you're getting a billing statement at the account level, and if you've mapped an account to a particular process, workload, or team, you're able to very clearly say this is what it's costing you to do what you do in AWS right now. So this is an example of a multi-account approach. This is a common use case where some of the approaches here are where a customer will create core accounts around security, logging, shared services, and network. Some customers actually then go and create developer accounts. They'll create, I've got some partners who, for every developer they have, they create them their own AWS sandbox account, and that's where they do their work to test their code and get things ready before they move into more of a common staging environment. And then each team or group has its own set of accounts. They'll have a prod account, a pre-prod account, a dev account, maybe a shared services account that's just for that team. And then all of that might be connected to an on-prem data center. So there's lots of different areas and things that you might find when you start looking at customers who are doing a multi-account strategy, and you can quickly see how you might be able to grow well beyond that one account that customers initially start with. Well, one of the challenges here is, well, great, I've got all these accounts and I've got this awesome multi-account strategy. I've got people who actually need to interact with and get into that account now. What am I going to do now? I mean, it's pretty easy to go in and set up one account and establish the roles and make sure that that's all in place. But how do I actually do that with any sort of sane timeline and ensure that I can do this consistently for every one of these accounts that I may need? This is my first boxed water, by the way. There's actually setup that exists when it comes to Okta and AWS to support that multi-account strategy that I want to walk through. And then we'll talk about some strategies to actually see how you can automate that. So for that master account, you just need to pick one account that you're going to consider to be your master account. It doesn't have to be an account named master, but some account that you're going to use that Okta is going to use to be able to access all the other accounts. It's really kind of almost a jump box. So you're going to define your Okta identity provider in that account. You are going to define one IAM user that Okta is going to use. That's going to be used for two purposes. One, it's going to be used to query all the roles in that master account so that you can actually map those roles to your users so they can access your AWS account. And then you're going to define all the other roles and policies for the things that people need to do inside of your AWS account. And then, so you can do that once. Then for all your child accounts, for each one of your child accounts, you're going to have an Okta identity provider created again. You're going to define an IAM role in that master account, or in that child account, which is for the master account to query. So we call this a cross-account role. You're actually going to create that role and grant the master account number permission to assume that role and be able to use those temporary credentials to look into that child account. It will have enough permissions that allows it to query a few read-only APIs. And then you're going to go through and define all the other roles and policies that people and things would need to be able to interact with that child account successfully. So here's another look at this. We've got master account and our child account. Okta's initially going to use that IAM user to learn about the roles that exist in that account, as well as to discover and learn about all the roles that exist in the child account. And then you're going to be able to take and use the Okta to be able to actually map users to roles. If you're using Active Directory or LDAP as well, there are ways that you can go in and just do this all through setting up the right groups and roles and mapping the users in that way, and then importing that all into Okta. So there's an alternative way to do that if you want to, and that's actually documented out on the Okta support site. And then once that exists, I've got everything in place. From Okta, I'm now able to federate into multiple accounts. In this case, I've got my master and my child account, but that can be to many child accounts. So this type of strategy of thinking about what that setup needs to be and making sure you have a way to implement that setup is important when it comes to a multiple account strategy. Now, how is that going to work for me when I am talking about maybe arriving at hundreds or thousands of accounts? Oh, sorry. This is what it looks like. So if I was doing multiple accounts, I would get a list when I try and federate in AWS that would give me each account that I have access to. And then if there were multiple roles in each account that I had access to, I'd have to choose the role. And the cool thing is it looks exactly the same with that command line interface. So if you have developers, for example, who might be interacting with multiple accounts, maybe moving code from their sandbox into a staging environment, they can also be presented with a list of which account and which role do you want to choose. Automation is going to be really key for you to be able to actually implement a multi-account strategy and bring your identity provider along with you. What's here on the screen is just an example of the create SAML provider call from the AWS command line interface. It's one line of code. I'm providing the file where the metadata XML file for Okta is located and providing a name to my identity provider. I can do this with the AWS command line interface, which is what you see here, or I can use any one of the AWS software development kits to write this same code. So the fact that I can create that identity provider, which is the first step, and the thing that needs to be present in every account, starts to show me that I have the ability to write some code and actually be able to automate this setup, and maybe as soon as I create a new account, build this in as part of my overall account setup so that the moment my account is ready to go, it's plugged in with my identity provider and I'm following my prescribed best practices right from the get-go. Another way to do this is, or a part of this strategy is potentially using AWS CloudFormation. So CloudFormation is a way for you in a JSON or a YAML format to actually be able to define your infrastructure configuration on AWS. And then you run that and it creates the appropriate resources that you have defined in that template in the AWS account you're running it against. So if I were to do this with CloudFormation, 2 parameters I would want to pass in are the actual XML for the metadata and the ID of that master account. So we're building a template here that would actually run in our child account. And what it's going to do is it's going to define the identity provider. So it's going to take that metadata XML and create the identity provider. Because I've given it the master account ID, it's going to create that cross-account role that allows the master account to learn about what roles are in my child account so that it can issue those temporary credentials. And then optionally, this template could also create all the other roles and policies that are needed for my users to actually be able to interact with that account. And that really depends on, do I have enough information at this point in time to actually be able to define that or not, or maybe I just create some generic roles for an admin to come in and do the rest of the setup later on based on how that account's going to be used. That's really, depends on how you're treating and what knowledge you have about that account at that time. So here's what the workflow might look like. We're going to use AWS Organizations. So this is a cool service that allows you to really take advantage of the multi-account strategy. People who are adminning an AWS account, how many of you actually set up an AWS account from scratch before? Right, so you have to go in, you have to go sign up for an account, you have to enter a bunch of information, you have to enter your credit card. It's like 3 or 4 screens. And until a couple of years ago, every time you wanted a new account, you were going through the same setup process. And at scale, that really doesn't help. And it's error prone as well. Somebody might fat finger an email address or they might put in the wrong billing information and it gets caught in a fraud check, et cetera. So Organizations is a way for you to, with one line of code, be able to create a brand new AWS account that will automatically be a child account under what you defined as your master account. It also allows you to define what we call service control policies that you can push down to all of your accounts to define what are the whitelists and blacklists for which services, AWS services can actually run in that account. And then you can also group accounts into logical definitions for you, which we call organizational units. You might have dev, test, prod, you might have finance, HR, security, whatever makes sense for you. And then you can actually push those policies down against those organizational units. So in this workflow, what we have is we have our master account. We're calling the create account API, which is going to create a child account for us. And in under a minute, we will have a new account ID that says, okay, here's your new AWS account. And then for my master account, I can actually have a little bit of code. And there's a couple different ways to do this. This is just one example. I've got a little bit of code that's going to run. It's going to reach out to an S3 bucket I have tied to my master account and get that Okta metadata XML file that I've stored there in advance. Now that it's got that XML file, it's going to call a CloudFormation template to create the identity provider in that child account. So I'm going to pass in the metadata XML and the ID of that master account. And then I might call another CloudFormation template to create the roles and policies that I need in that specific account, depending on how much I know about that account at that time. So the ability to kind of workflow this and string this all together exists because of the fact that you can do this all programmatically. As an optional step, I may also go in and run, and now that I've got a new account, do all the appropriate mapping in Active Directory for my users to know which roles and which accounts they have access to now that I've added another account. So with our customers who want to be able to execute on this multi-account strategy, we released a solution under a year ago called the AWS Landing Zone Solution. And this is more of a full-blown way for customers to execute and run a multi-account strategy, but allowing them to also make sure that the right security controls and governance are put into place at all times, baselining their accounts and having an account vending machine, which we'll get to in a minute. And that the fact that it can be automated, that in just a few clicks, providing a few parameters, they can automate all of this creation and hand it off to end users to actually be able to vend this information out for themselves. And an even cooler thing here is that this is all customizable. This was built on top of existing AWS services, so it's a lot of CloudFormation and a lot of Python code that anybody has access to that they can go in and customize it to meet their specific use cases. The key thing I want to focus on here is the fact that you can baseline accounts and that there's an account vending machine. So this is the overall generic setup of a landing zone. You will have a master account, and then you get 3 accounts. It creates a shared services account, a logging account, and a security account. And so the purpose of those is just like it sounds. Shared services is where you're going to put things like maybe an Active Directory installation. The log account is where you're going to aggregate all your logs, both from AWS services and potentially from your applications. And the security account, that's where the security team plays. That's where they're maybe, they'll have all their security tools running. If they're using Amazon Guard Duty to detect incidents in the account, all of those findings will be forwarded to that master account. And it's really a place where any other security tools that your company needs or your security guys want, that would probably be a good place for them to be isolated and located. The account vending machine, this is the really cool thing. So what Organizations does is it allows somebody to go in and get access to a service catalog to say, I'd like to launch and create a brand new account. And they fill in a couple of parameters around the email address of the owner of that account and potentially some information around the networking for that account. And then a workflow kicks off that goes through and it creates that account. It applies all the appropriate security baselines to it, does all the configuration to make sure all the auditing and logging for that account is written to the right account, applies any network baselines, gets the account linked up with the shared services account so that you can use Active Directory, and gets really everything baselined so that at the end of the day, as an administrator, you feel comfortable saying, okay, team, here you go. Here's a brand new AWS account. Go out and do the things that you need to do to take advantage of all the value prop that you get out of AWS for the elasticity, the scalability, the self-service, et cetera. I feel comfortable with you in this account because I've got all the right configurations and controls in place now. And I've been able to do that in a very automated way, very hands-off, it's very repeatable, and it's customizable so that you can do this at scale. So when we think about Okta, once again, you can do this, it's customizable. So you can fold all those baselines I've been talking about as far as making sure you have the right identity provider set up and the right roles in place, where you can add into this configuration as part of that account baseline. I'm going to add in the Okta configuration. I'm going to add in the identity provider's definition. I'm going to add in the cross-account role that's needed to be able to discover all the other roles in my account. And then I'm going to go add in all of the specific roles that might be needed for my account. So if you're looking at a multi-account strategy, you have Okta and you want to bring your identity provider along with you, I'd highly encourage you taking a look at the landing zone solution and how you might be able to customize and fold that in to your overall identity strategy and make sure that your strategy can actually keep up with the pace that you're going at AWS. So awesome. So we've had a chance to kind of review some general best practices and make sure we level set as far as AWS goes. We've talked about ways to kind of move yourself beyond that browser-based management console and maybe allow a little bit more hands-on keyboard, allow some more automation and consistency about the way you interact with your AWS environment. We've talked about kind of the new direction we see our customers going when it comes to a multi-account strategy and where Okta can fit into that and how you can bring your identity provider along as you go through that strategy. So with that, I'd like to first thank everybody for coming out and sitting here. It's been awesome talking to you guys. I really appreciate it. And I'm here for as long as you need me to answer questions or dodge your questions, depending on what you ask me. And we've got a mic wandering around here, so feel free. Thank you.
Thank you, everyone, and anyone who wants to stay. Scott is going to give us more of his valuable time. I'm going to, because we're still recording, I'm going to ask you to ask your question into the mic. And you were the first hand I saw, sir.
Two questions. Can permission boundaries have negative statements in them? So, for example, no 000 inbound role is allowed on a dev account.
So, sorry, you might say it again.
Can permission boundaries have negative statements in them? Things like you are not allowed to have a 000 inbound rule on a dev account.
Yeah, so as far as like the way you define the VPC, for example, or yeah, for
so like high-level VPC config to
so
boundaries about.
It's really whatever you can define, whatever the IAM policy language will allow you to define as far as what's allowed for a policy is the same thing you can define with a permission boundary. So I don't have a specific answer if you can or can't, but if IAM will let you do it as just creating a policy, you can do the same thing with a permission boundary.
And
I can look it up for you though, and we can research it.
And the second question was related to landing zones. We can't use that, unfortunately, because we're a Rackspace customer.
Okay.
So how would you add landing zone style automation to an existing account cluster that looks somewhat similar to what landing zone builds, but we already have all the accounts?
So you have a solution that's like landing zones, but not landing zones, is what I'm hearing. Is that right? Oh, you don't. You don't have landing zones at all, but you want to be able to. Okay, the same automation, but by hand. So what you could do is every time you create, so the question was how do I do something like the landing zones automation without having landing zones? And so there's a little bit of manual effort. So my recommendation would probably be is that CloudFormation approach that I talked about, so that every time you get a brand new account, step one is probably turning on CloudTrail so that you're auditing all of your API calls. Step two is go in and run this CloudFormation template that already knows about the XML file and knows about the master account ID, and it just sets up that configuration so that it's there as part of the account right away. And that should take like under 5 minutes for that template to run. So you can have that template done and somebody just manually goes and runs it as part of your kind of initial setup steps would be a way to make that happen.
Hi. In your slide you mentioned IAM plus Okta equals access to the console.
Yep.
Do you know if that also works for the CLI access to the ECR service to be able to authenticate and grant access to pull Docker images?
I would have to test it to make sure, and I'll give you, if you stop by afterwards, I'll give you my card and we can trade information on it. That's an awesome thing, and Tom, maybe that's another thing we can dig into as well. I have not tested that yet, but we can try it out and see if it works, or maybe that's another work item that we create.
Thank you.
Yep.
Hello. You discussed a lot about long-lived credentials, rotating or removing them, and also about the Okta integration with that one-to-many model, the many accounts. So I know you need to have the IAM user built in there and give Okta some rights to read that account and then through all the other child accounts to enumerate the roles. What about rotating that API key that Okta is using? Is there any automation in place on either side to refresh that without losing?
Sure. So I've got somebody who might be able to help here. Tom, is there an API to actually, I mean, I know you can rotate them on the AWS side, but is there an API to refresh those keys, to like push those new keys in automatically, or would that be a manual step?
Okta's.
The access keys that are needed for that master account, the IAM key.
Okay. All right.
So that would, it doesn't completely eliminate the named IAM users, but it gets you significantly better. And, we'll see what we can do about that over time as far as how we might partner to enable that to be a little bit more clean.
Great. Thanks.
Anyone else?
Over here.
I'm taking three over here.
behind you.
Allow me to take someone on this side of the room.
There's a question.
I saw a hand up over here.
How does the AWS CLI command line tool handle app-specific MFA requirements?
So say that again.
So I'm not sure if this is like a known issue, but when there's a MFA policy required for the application, the CLI tool, how does that handle that flow?
If you it only works if you're using credentials tied to a named IAM user. So then it can enforce MFA, but it's a good point of how do I pass it to you. I'd have to go test it, to be honest. I federate it and everything, so I don't have to do that, but we can go and test that, and once again, I'll trade you. Oh.
My question is, the groups that you map to the AWS roles, what is generally the trend that you see of where those groups are managed? Is that more on the AD side or they use Okta Groups, and is there an advantage one over the other?
So you're talking about like managing the groups as far as which roles they have access to in the AWS account?
Right.
I think it's really, I mean, I just do it in Okta in my test environment. I just map individual users to roles. I think if you're using Active Directory, that's probably the path you'd want to be able to have more consistency around managing, because you've probably got other groups defined in Active Directory that have other purposes already. So continuing that mapping for your AWS accounts and for those roles probably makes sense to keep that in Active Directory as well. But it kind of depends on what your appetite is for each of those things. But I'd say generally the trend I've seen is that people, if they have Active Directory, regardless of the identity provider, that they're managing that stuff in whatever their corporate directory is of choice. If they're using the identity provider's directory as their directory, they're managing it there, or if they're using AD, they're managing it in there.